Today we're going to be looking at graphing quadratics. If we've got it in this general rule, y equals ax squared plus bx plus c, a, b and c are constants, remember, so any numbers a cannot equal 0, because if it equals 0 then it's not a quadratic. And we know that that's the polynomial form. Y equals x squared is the simplest quadratic equation that we can graph, and it is a parabola. Now we should all know how it looks like, so I'll try and draw it as best I can over here. So I've got my axes, excuse the lines, I'm doing this freehand, and a parabola. Y equals x squared looks like that. X is 1, y is 1. Okay, that's the point right there. Now, this has an axis of symmetry, and I'll do that in red. Axis of symmetry right here, which means it splits the parabola in half. Right in there, we should already know that. That's the axis of symmetry. This number in front of it is a number 1. It is a positive, so a positive graph looks like this. A negative graph looks, of course, upside down like that. The vertex of this graph is right there where it changes, and of course this one here is 0 and 0, excuse me. Then of course we can change this by going inside here, making it steeper or making it wider like this. Okay, so we'll be looking at those. Now we can change this polynomial form to the turning point form, because that's easier for us to graph. Now the turning point form will look like this. A, H and K are numbers, and of course that tells us the transformations that the graph takes place. A does this. If A is greater than 1, so 2, 3, 4, 5, then the graph becomes steeper, so it's narrower. If A is less than 1, then the graph is more broader. This is called dilation. So this is the word that we want to use of a factor A, because we don't know what the A is, from the x-axis. Of course, if the A is negative, then it's reflected, and that's what we say. It's inverted upside down, but we say it's reflected in the x-axis. This section here, x minus h all squared, does this. H moves the graph left or right, depending, of course, if it's a positive h or a negative h. We say that the graph is translated h units in the positive or negative direction of the x-axis. Now this is what happens. We solve for h. If h is bigger than 0, then it moves to the right, and if h is less than 0, it moves to the left. You don't really need to solve it. It's always going to be the opposite of what's in here. So if it's a negative in here, it moves to the right. If it's a positive in here, it moves to the left. The k shifts it up or down, and we call this a vertical translation. Okay. Now, how much? If it's a positive, it goes up. If it's a less than 0, so it's a negative, it goes down. How many units does it go down? It goes down the k, whatever that number is. So if it's positive 4, it goes up 4. If it's negative 4, it goes down 4. Okay, let's sketch this one here. Y equals x squared minus 4. So this is the normal parabola, but this part here, because it's a negative, it shifts it down by 4 units. So we, again, excuse my drawings. I'm doing this freehand here. There's my y, there's my x. If I put the 0 there, -1, -2, -3, -4. This graph will go, instead of the normal parabola, which is this one in the dot, 0 goes through here, it's going to cross here. That's going to be the vertex. That vertex from there will go shift down 4 units. We should find out where it's going to cross the x-axis. Now remember that the x-axis, the x-intercept, y equals 0. So if we put y equal to 0, we get x squared minus 4 equals 0. X equals positive, sorry, x squared equals positive 4, so x will equal plus and minus 2. So it's going to cross there, and it will cross there. So drawing my graph, I'll change it to green. Okay, drawing my graph, again, excuse the way the graph draws, passes through at -2, 0, comes down here, turns, bad graph, I apologize for that one, turns right there. And we can label it y equals x squared minus 4. Okay, the next one. Sketching this one here. Now this one is still a parabola, but this, because it's inside, remember it shifts it opposite, and this inverts it. So if I was to sketch them all, I've got, this is a quick sketch, this is y equals x squared. I'm not going to put any numbers on here. The plus 2 will shift it to the left, -2, so it will look something like this. Don't know where, I'm not going to work that out just yet. And then the negative part outside, this part right here, will flip it upside down. So at -2 right here, which is right there, it flips it upside down like that. Now it will cross the axis somewhere. Remember, y equals 0 there. So when we work that out, if y equals 0, we get x plus 2 will equal 0, so x will equal -2. So this here really crosses at -2. This one here, okay, as a dilation, has a shift, and it's to the right, opposite of that, and as a shift, a translation up. Sorry, I should say use the word translations. So if I was to do this all, and it's always good to have the vertex in perspective. Vertex normally is there at the 0, 0. Let me just put y and x here. This one's going to be shifting 1, 2 units this way, so it's going to be there, and then up 1. So the vertex is going to shift there. It's not -3, so it's non-inverted, so it's just going to be there. You can work out where it crosses the y-axis first. Y-intercept, put x equal to 0, so you can try and get a better graph. So you get y equals 3. 0 minus 2 is -2, square it, becomes 4, and you've got plus 1, so it's going to be at 13. So I'll put 13 right over there, and I know that my graph is going to go through there. That's the y-intercept. There's the vertex, so here it's going to change over like this. So try and do the best graph that I can, and that, put my arrows on there, that's y equals 3. X minus 2 squared plus 1. Another one here. This time we know that that negative is going to invert it. That's a translation in the opposite direction, so in the negative direction, and that goes up, so in the positive direction translation. So again, let's just draw up these axes. We can write everything down. I'm not writing everything down here, I'm just mentioning it. So it goes to -1, that's the first translation. Then it goes the up 3, so positive translation along the y-axis, so up 3. So that's where my vertex is now. But instead of looking as a positive, because of that negative in front of it, it needs to look like this. And it's going to cross. It will cross, should cross both axes. So it doesn't matter which one you find first. Y-intercept, put x equal to 0. That's what that means. So if you put x equal to 0, get y equals -. 0 plus 1 is 1. Square it is still 1. And plus 3, that gives me +2. And the x-intercept, you put y equal to 0 and you solve it. So I get -x plus 1 squared plus 3 equals 0. Bring the +3 becomes negative, and because of this negative, and that's going to be a negative, I'm just going to write x plus 1 all squared equals +3. Take the square root, so x plus 1 equals plus and minus the square root of 3. I'm not going to be bothered working that out. So x will equal -1 plus or minus the square root of 3. So you know roughly what it is. So we can write it like this: -1 minus the square root of 3 over here, and -1 plus the square root of 3 over there, and this is at 2, so we know it crosses here. We've got everything down, so I know it's there, 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 and there. I know it looks like this, so I'll quickly just do a quick drawing. Pretty bad scaling for me to get this, and it will look something like this. If you do it on graph paper, you'll get a better picture. And that's the 4D questions.